Hello everybody and welcome back to Advanced Maths. Today we're looking at the IB Analysis and Approaches Standard Level Paper 1 from May 2021. I've linked this down in the description below where you can download it from my website. This is a non-calculator paper, so we won't be using a calculator for any calculations today. This paper is best if you do it yourself before you see my solutions, or you might want to download it and print it and do it at the same time as I'm doing it. You can pause the video before each question and then press play if you get stuck, or if you want to see if your answer matches mine. If you're really struggling, you can just press play and see the entire question all the way through from my worked example. However, you will learn more if you do each question yourself before you look at the solution. And with that, good luck. We're going to go through the entire paper now. It's going to take a while, so let's get focused, let's get comfortable. And we'll start with question 1. So here question 1 says the graph of y equals f of x for minus 4 is less than or equal to x is less than or equal to 6 is shown in the diagram. Write down the value of f of 2. Well, to do this, we're just going to put 2x equals 2 into the function, and when we do that, we get 6 out. And that's just by looking at the graph, we see that putting 2 in, we get 6 out, like that. So the answer to question 1a, I is 6. F of 2 is 6. Now, what's f of 2? Well, it's the same as putting 2 into f, getting an answer, and then putting the answer back into f. Well, we already know what f of 2 is, that's 6. So it's the same as f of 6. And so we put 6 in, we go down from 6 and across, and we see that the answer is minus 2. When you put 6 into this, you get minus 2 out. That's 1a done. Let's now look at 1b. So here we've got g of x is a half f of x plus 1 for the same domain, and we have to sketch it on the graph of both. Okay, so here let's just think about the function and think about the graph transformations. Firstly, we're going to do a vertical stretch by scale factor 1/2 because we're multiplying f of x by 1/2. And that means we squash everything by a scale factor of 1/2. Every y coordinate is halved, and we get this. Now we add 1, and we shift everything up by 1 space. And it looks like this. We have done question 1, A and B. Okay? Now, let's look at question 2. The diameter of a spherical planet is 6 times 10 to the 4 kilometers. Write down the radius of the planet. Well, that's easy. That's just half the diameter. We half 6 times 10 to the 4. We get 3 times 10 to the power 4 kilometers. Remember the kilometers on the end. The volume of the planet can be expressed in the form pi times a times 10 to the power k kilometers cubed, where 1 is less than or equal to a is less than 10, and k is an integer. Write down the value of a and the value of k. Okay, so it's the volume of a spherical planet, so it's the volume of a sphere. We're going to use the equation for the volume of a sphere, which is given here. The volume is 4/3 pi r cubed. And we're going to substitute in the radius, which we just found out, is 3 times 10 to the power 4, like that. We've replaced r by that. Now, we cube everything in that bracket. 3 cubed times 10 to the power 4 cubed. Well, 3 cubed is 27, and 10 to the power 4 cubed is 10 to the power 12. Like this, which simplifies to this. We're getting closer. Remember, we're doing this all by algebra, and we are not using a calculator because it's a non-calculator paper. 4/3 of 27, we divide by 3 and times by 4. 27 divided by 3 is 9, and times by 4 is 36. So 4/3 of 27 is 36. We're getting very close to what the question asks for. Now, we need to convert it so that the it looks like this in brackets, but the 36 is not between 1 and 10. So we just need to adjust that slightly, and what we'll do a clever trick here. We'll change the 36 into 3.6 times 10, because that converts the 36 into a number between 1 and 10 times 10. And we get this, 3.6 times 10 times 10 to the power 12. Just notice the 36 is 3.6 times 10 times 10. This is the clever trick I'm telling you about. 10 times 10 to the power 12 is 10 to the power 13. And we get this. And so here A is 3.6 and K is 13. And we have completed the question. We've already done question 1 and question 2. We're making good progress. Ready for question 3? Okay, so question 3. Consider an arithmetic sequence where U8 is equal to S8 is equal to 8. Find the value of the first term, U1, and the value of the common difference. Okay, so we're going to use these formulas which are given to you in your formula booklet. The nth term is given by UN, and the sum of the first n terms is given by Sn. I think you're familiar with these. We substitute in 8 for n in the first one, and 8 for n in the second one. We also remember that U8 is equal to 8 as well. We get this, and that simplifies to this, which is also that. Okay, we've substituted the numbers in, and we've simplified a little bit. We can divide by 4 on the second one to get rid of the times by 4, and we've got two simultaneous equations here. And it's quite nice that they've both got 7D and 7D, because that's going to simplify them very easily. We're going to set them on top of each other, and we're going to subtract. 2 minus 8 is minus 6. 2u1 minus u1 is just 1u1, or u1. And then 7d minus 7d disappears. We've got minus 6 is equal to u1. Very nice. We've already found the value of the first term. Now to find the difference, we're going to replace u1 in one of the equations with minus 6. We're going to move the minus 6 to the other side, get 14 is equal to 7d, divide by 7, and we get d equals 2. And that is the final answer. We've got u1 equals 6 and d equals 2. Perfect. 5 marks. That's question 3. Let's move on to question 4. Okay, question 4. A research student weighed lizard eggs in grams and recorded the results. The following box and whiskey plot shows a summary of the results where L and U are the lower and upper bounds quartiles respectively. The interquartile range is 20 grams and there are no outliers in the results. Find the minimum possible value of U, and hence you're going to find the minimum possible value of L. Okay. So the key fact here is that the interquartile range is 20 grams and there are no outliers. And for this you're going to need to remember what an outlier is. So you should remember, and this is a key fact from your textbook, that an outlier lies below Q1 minus 1.5 times the interquartile range, or above Q3 plus 1.5 times the interquartile range, where Q1 and Q3 and the lower and upper quartiles. Okay, that's a key fact. And so because we're looking at U here, we're looking at the upper quartile, and we know that 75 is a long way from U, and it's not an outlier. We know that 75 is the biggest piece of data, the biggest data point, and it's not an outlier. So 75 must be below the threshold to be an outlier. So 75 must be less than or equal to Q3 plus 1.5 times the interquartile range. So I'll just repeat that. 75 is below the threshold to be an outlier because it's not an outlier. Because it says there are no outliers. So 75 is less than the threshold for an outlier. 75 is less than or equal to Q3 plus 1.5 times the interquartile range. And we know the interquartile range is 20, so we can replace the interquartile range with 20. And 1.5 times 20 is 30. We take 30 off both sides, and we get 45 is less than or equal to u. So the minimum possible value of u is 45. U cannot be smaller than 45. And then we know the interquartile range is 20, so if 45 is the smallest value of the upper quartile, we take 20 off and we find the smallest value of the lower quartile. 45 minus 20 is 25. We found the lowest value for the upper quartile and the lowest value for the lower quartile as well. And we finished question 4. Okay, question 5. Consider the functions f of x equals minus x minus h squared plus 2k, and g of x is e to x minus 2 plus k, where h and k belong to the real numbers. Find the derivative of f. Okay, so we've got f here, and we're going to differentiate it. To do that, we're going to need to expand the brackets first. So we expand the brackets like this. Remember, the minus sign at the front is going to cause confusion, so we have to be really careful about that. We expand that bracket, we get x squared minus 2hx plus h squared, using the crab's claw to expand that double bracket. And then we make everything in that bracket negative because there is a minus sign at the front of the bracket. And we get this here. Okay, just be careful with this minus 2hx here. That is a minus 2hx, so that will become positive. Okay, and we've differentiated as simplified f, expanded bracket for f. Now we can differentiate it. And when we differentiate this, the minus x squared becomes minus 2x, and the plus 2hx becomes 2h. Everything else is just a number, it disappears. And so it differentiates to become this. The minus h squared and the plus 2k on the end are just numbers, they are not x's, they disappear. And so we've differentiated f, we've got minus 2x plus 2h. Okay, the graphs of f and g have a common tangent at x equals 3. Show that h equals e plus 6 over 2. Okay, so the fact they've got a common tangent means that they have the same gradient at x equals 3. And, you know, if we talk about gradients, we talk about tangents, it does make sense to differentiate the functions. Luckily, we've already differentiated f. And you will find that in exam questions, the first part of the question leads on to the second part. So the fact we had to differentiate the f first gives us a hint that we'll have to use that later on. Anyway, it's time to differentiate g as well. So we're going to differentiate g, and when we differentiate g, it just comes e to the power x minus 2. That's just using the chain rule, the differentiating exponentials. And they've got the same tangent at x equals 3. So the value of these two derivatives at x equals 3 must be the same. We're going to put x equals 3 into these. And we're going to simplify like this. And we get e to the power 1, which is just e. So these two things must be the same because they're the same, they've got a common tangent, so they've got the same gradient at x equals 3. So the derivative is the same. Make them equal to each other, rearrange, and divide by 2. And we've shown that e plus 6 divided by 2 is h as required. Perfect. Now hence show k equals e plus e squared over 4. And we have to use the information that they have a common tangent again. And when they have a common tangent at x equals 3, that means they also go through the same coordinate. So we already know they've got the same gradient, they also must go through the same coordinate as well. And that means they'll have the same y coordinate, or they'll have the same value at x equals 3. So we're going to substitute x equals 3 into these, like this, and just look at the g. We've got e to the power 3 minus 2, that's e to the power 1, or just e. So that simplifies very nicely to be e plus k. And we're going to make these two things equal to each other. So these two are equal to each other because they have the same y value at x equals 3. again using that phrase common tangent. And we're going to take k off both sides, like this. And we're going to try and simplify and rearrange that equation there, hopefully to get k equals e plus e squared over 4. Now we rearrange slightly, we get this. Just moving the minus 3 minus h squared to the other side. And we're going to expand that bracket, that double bracket, 3 minus h times 3 minus h, and we get this. Now the h's can now be replaced by e plus 6 over 2, because we know that h is e plus 6 over 2. So e plus 6 over 2 replaces all the h's like this. It's the same equation, we just replaced all the h's with that. And we've got minus 6 divided by 2, that becomes 3. So that we've got minus 6 multiplied here, and we've got divide. Minus 6 divided by 2 is 3. So that simplifies very nicely. And then we've got e plus 6 divided by 2 squared, which looks like this. But here we've got the 2 times 2 on the bottom, and that's like a 4. So we can immediately take a quarter outside. We just expand that bracket first. And we take a quarter outside like this. So the denominators are 2 here. Because we multiply those together, it's like divided by 4, which is like a quarter. We expand that bracket, and we've got this. And then we expand the quarter times that bracket, and we get this. Okay, we've got very close. Let's see if we can simplify this now. So we've got a minus 3e and a plus 3e, that will cancel. We've got a plus 9 and a plus 9, that's 18, and we've got minus 18, that will cancel as well. And so we've got some really nice cancellations straight away. And we're left with e plus a quarter of e squared, which is actually exactly what we wanted to show. And we managed to get to what we wanted it to be. K equals e plus e squared over 4. Done. So quite crazy algebra there. You might want to rewatch my answer to part C a few more times so you fully understand the logic and the steps, and you're able to do it yourself. Okay, let's move on. Question 6. Here we're going to show that sine 2x plus cos 2x minus 1 is equal to 2 sine of x times cos of x minus sine of x. Okay, so here I'm going to start with the more complicated looking side, and here I think the one with 2 x's on both sides, on both trigonometry parts, is the most complicated side. So my advice always here is to start with the side that looks most complicated. And we're going to replace sine 2x with our formula for the double angle formula, and we're going to replace cos 2x with 1 minus 2 sine squared of x, which is also our double angle formula. So we replaced them like that. Now we're going to try and simplify. The 1 minus 1 disappears, and we simplify. Now we can factorize 2 sine of x out of everything, like this, and we get what we wanted. We get what the question asked for. Just look at how I factorize that. Make sure it makes sense in your head. You might want to expand that bracket so it really makes sense to you how I did that. Okay, we've done part A, and we've got 2 marks for part A. Now, hence or otherwise, solve sine 2x plus cos 2x minus 1 plus cos x minus sine x equals 0. For 0 is less than x is less than 2 pi. Okay, now I'm immediately noticing the similarity between part B and part A. And you will always notice this in IB questions where part B follows on from part A. And so the cos 2x, the sine 2x plus cos 2x minus 1 part, that can be replaced by our part from part A. So we replace that like this because we know those two blue parts are the same. And now I can see that we've got the same bracket twice, because actually the cos x minus sine x on the end is another bracket like that. And there's one of those. So I've kind of factorised a cos x minus sin x out of both parts of this equation. And so we can simplify this like this, where it's sin x plus 1 times, 2 sin of x plus 1 times cos of x minus sin x is equal to 0. And this is really nice because this is kind of like a quadratic where the first bracket is either 0 or the second bracket is equal to 0 because they multiply to make 0. Okay, you might want to pause the video there and just read through the algebra so it makes sense in your head. Okay, take a moment to explain that to yourself. If you're happy, let's keep going. So either the first bracket is equal to 0, and therefore you can write 2 sin of x plus 1 is equal to 0, or the second bracket is equal to 0. Cos of x minus sin x is equal to 0. I'm going to solve these equations. So the first one we divide by 2, sin of x equals minus half, and we move the half to the other side as well. Move the sin of x to the other side on the other one, and we divide by cos of x, and we get sin of x divided by cos of x is tan of x. So we've solved those equations using a little bit of algebra. And for this, you must have memorized your special angles, because we have to solve these now without a calculator. And so for sin of x equals minus a half, you should know that is minus pi over 6. And for 1 equals tan of x, that is equal to x equals pi over 4. Okay, that is just knowledge of your special angles that you should have memorized before the exam. If you've not memorized that yet, you should memorize that. It is really important. Okay, we're really close. We just have to find where they repeat it, because it does say in the question it is between 0 is less than x is less than 2 pi, so there's probably repeated solutions. So now we need a cast diagram, and let's focus on the sin of x equals minus a half first. And when I do that, I get it is in the negative quadrant, because we know sin of x is equal to a minus number. Sin of x is equal to a minus a half. So it's in the tan quadrant and the cos quadrant, because they're the quadrants where sin of x is negative. We just remember we know that sin is positive in the sin quadrant and in the all quadrant. Okay, so we are looking for solutions in these two quadrants. We can reflect the angle into the tan quadrant as well, and we're looking for solutions around here. So the first angle is going to be this one, where we go around from 0 all the way around until we meet the first angle. And that's going to be pi plus pi over 6. And then the second one, we go all the way around, nearly 2 pi, but just stop short a bit by pi over 6. So the first angle, this one, is go around to pi and then a bit further by pi over 6. So that's pi plus pi over 6. And we need to add those two together. And then the second one is going around all the way nearly to 2 pi, but we're stopping short by pi over 6. So we do 2 pi minus pi over 6. Okay, those are two angles, and we're going to have to simplify them. Pi plus pi over 6 is 7 pi over 6. Just think of pi as 6 pi over 6. And then you can make it as a common denominator. And then 2 pi minus pi over 6 is like 12 pi over 6 minus pi over 6. So you're making a common denominator there with denominators of 6. And we get x is equal to 7 pi over 6 or 11 pi over 6. Those are the two answers. Okay? Again, take a moment to rewatch that if it's a bit confusing. It is a bit of a tricky question, this one. If you cannot remember your cast diagrams, I've got a video on cast diagrams that I will link below. Next one. Tan of x is equal to 1. And we know that's when x is equal to pi over 4. But this is repeated in the tan quadrant as well, because tan is positive in the all quadrant and in the tan quadrant. So we're also going to draw another line in the all quadrant, and we're interested in that point there. And that's when you go around to pi. So you start here, go around to pi, and then you go a bit further, you go pi over 4. So you go pi plus pi over 4. And we need to common denominator, so that's 4/4 pi plus pi over 4 is going to be 5 pi over 4. And now we've found all solutions. That is the final answer. Question 7. Let f of x equals mx squared minus 2mx, and the line y equals mx minus 9 meets the graph of f at exactly 1 point. These two graphs meet each other at exactly 1 point. And we're asked to show that m is equal to 4. Okay, so when it says meet, when two graphs meet, that is talk about intersecting, and that means they are equal to each other at that point. So whenever you see the words meets the graph, that means they intersect, they're equal to each other. And it also says exactly 1 point, which sounds a lot like has exactly one solution, which is like the discriminant. And so that phrase exactly 1 point always just means you're going to use a discriminant. So we make them equal to each other. We make the two graphs equal to each other, and we rearrange like this. And we move the minus 9 to the other side. We get this. We get a quadratic, which we can use a discriminant on. And we know that a is equal to m, b is equal to minus 3m, and c is equal to 9. And the discriminant is equal to 0 because there is one solution. They meet at 1 point, there is one solution. Substitute the values in, like this. And we're going to simplify that. We get this, which we can factorize, and therefore m is equal to 0 or m is equal to 4. Those are the two possible solutions. M is equal to 4 as required. It cannot be equal to 0 because if it was equal to 0, it doesn't make sense in the context of the question. The f of x will just be 0 and y will be minus 9, and they would never meet. So we ignore m is equal to 0 and we just show m is equal to 4 as required. Absolutely done. Excellent. The function can be expressed in the form f of x equals 4 times x minus p, x minus q, where p and q are real numbers. Find the value of p and the value of q. Right, all we're going to do now is factorize. So you get the function here. We substitute m is equal to 4 in, and therefore 4x squared minus 8x is our function. And we factorize like this. And that's 4x minus times x minus 2. That's the same as x minus 0. So I'm just converting that 4x into 4 times x minus 0 because I want to see what p and q are. So p and q are 0 and 2 respectively. Good. Let's keep going. We need to now find f of x in the form 4 times x minus h squared plus k. And this is vertex form, so we're going to need to complete the square. So we start with the function 4x squared minus 8x, and we factorize the 4 out. Then we complete the square as we normally do. If you can't remember how to complete the square, I have a video on that, and I will link it at the top of this video on a card. We simplify, and then expand the bracket, and we get 4 times x minus 1 squared minus 4. So therefore, h is 1 and k is minus 4, as it asks for in the question. It does say x minus h here and x minus 1. So h is positive 1, and you have to get it to be positive 1, not minus 1. Very good. Finally, part D, it says, hence find the values of x where the graph of f is both negative and increasing. Okay, so I think we're going to have to graph this, aren't we? We've got the axis here, and it's got x-intercepts or roots here, and it's also got a vertex here. And that's just from knowing that the factorized form gives us the roots and the vertex form gives us the vertex. So we are graphing the key points of this function, and now we can do a quick sketch of what the graph looks like. It's a U shape because it's a quadratic. So you've seen the roots from the factorized form, we've seen the vertex from the vertex form, and now we can see that it is negative, that is below 0. So it's below 0 between 0 and 2, down this part. And it's also increasing, that means going up between 1 and 2. So it's negative and increasing between 1 and 2. So 1 is less than x is less than 2, like this. And we write it as an inequality like that. I will just repeat that. It is negative here. So it's below the x-axis, below the 0 here, that's negative. And it's increasing, it's going up at that point. At those points as well, between 1 and 2. Good. That's all of question 7. Let's do question 8 now. Okay, so it says let y equals ln of x over x to the power 4. And we're trying to show that dy over dx is 1 minus 4 ln x over x to the power 5. Well, we're going to use the quotient rule here. So this function here, ln of x over x to the power 4, is a fraction, so we're going to use the quotient rule. I've written the quotient rule over here, v du minus u dv over v squared. We're going to start with u is equal to ln of x, that's the top of the fraction, and x equals v equals x to the power 4. We'll differentiate those, Fantastic. And we can substitute those into the quotient rule now. Like this, substituting in everything as we go. Just be carefully substitute everything in the right order, in the right place. Like this. And we can simplify. So we've got x to the power 4 times 1 over x. That becomes x cubed. And on the bottom we got x to the power 4 squared. You multiply 4 times 2 and you get 8. And then we just rearrange slightly. And we can also factorize an x to the power 3 out of the top and the bottom. So you see on the top we've got x cubed and we've got 4x cubed. We're going to take the x cubed outside. We've also got x to the power 8, which can be split into x to the power 3 times x to the power 5. And that's really useful because now we can simplify really nicely. So that factorizing step there was the simplest way, just to find x cubed and x cubed, which can come out at the top and bottom. We cancel, and we're left with 1 minus 4 ln x over x to the power 5 as required. That is what the question asks for. Now, consider the function defined by f of x equals ln of x. For x is more than 0 and its graph y equals f of x. The graph of f has a horizontal tangent at point P. Find the coordinates of point P. And I've got a graph of a horizontal tangent here. The blue dotted line is a horizontal tangent. Horizontal tangent is flat. Horizontal means flat. So therefore the gradient of that tangent is 0, and therefore the gradient at that point of the graph is also 0. So horizontal tangent means at that point the gradient is equal to 0. Horizontal tangent means at that point the gradient is equal to 0. So that's what we're going to do. We're going to make the gradient equal to 0. And we've made our equation for the gradient, 1 minus 4 ln of x over x to the power 5 is equal to 0. And we can just focus on the top of the fraction here, because the only way to make a fraction equal to 0 is if the top of the fraction is 0. And so 1 minus 4 ln of x is equal to 0. We rearrange that, divide by 4, and then make it a power. So we convert the logarithm into a power of e. And we get x equals e to the power of a quarter. So therefore the x coordinate of the point P is e to the power of a quarter. We now need to find the y coordinate. And we're going to do that by substituting it into the original function. So we've got y equals ln of x over x to the power 4. We're going to substitute in like this. We're substituting in x equals e to the power of a quarter, like that. And we can simplify this really nicely. On the top of the fraction, we've got ln of e to the power of a quarter. The ln and e cancel, and that's a quarter on the top. And then on the bottom, we've got e to the power of a quarter to the power 4. Multiplying those two powers, we've got a quarter times 4 is 1. So it's just e to the power 1. And therefore, we've got a quarter divided by e, which is the same as 1 over 4e. Just converting 1 over a quarter over e to be 1/4 of e. We've now got the coordinates. We've got e to the power a quarter and 1 over 4e. Cool. That is the coordinate of p. Now, given that f double dash of x, the second derivative of f is 20 ln of x minus 9 over x to the power 6, show that p is a local maximum. So, we already know that x equals e to the power a quarter and f dash of x equals to 0. Pardon me. So now we need to test to see whether it's a maximum or a minimum. And it is a maximum if f double dash of x is less than 0. Let's concave down. So the rule is that if you've got a turning point, it is a maximum if the second derivative is less than 0 at that point. This is the rules about concavity and turning points. Okay, so 20 ln of x minus 9 over x to the power 9. X to the power 6, that should be, sorry. And we're going to substitute e equals a quarter into here. So we're going to substitute in e to the power a quarter. And when we substitute that in, it simplifies to be this. 20 times a half minus 9 over e to the power a quarter to the power 6. Sorry, that shouldn't be 9, that should be 6. Well, on the top, that is a negative number. So 20 times a quarter is 5, minus 9 is minus 4. And then on the bottom, it's e to the power a positive number, e to the power something, and that's going to be positive. So you've got a negative on top divided by divided by positive. A negative on the top of the fraction divided by a positive. And when you've got a negative divided by a positive, it is negative. And so far, therefore, the entire thing is negative. And so without actually reaching for our calculator, we can see that that fraction there is negative, a minus divided by a positive. And hence, the second derivative is less than 0, it is concave down, and it is a local maximum. Good. Now D, it says solve f of x is more than 0 for x is more than 0. So let's look at f of x. To see if this fraction is positive, let's consider the numerator and the denominator. The denominator will always be positive when x is more than 0, so x to the power 4 is always going to be positive, because you've got a positive number to the power 4, you're going to get a positive. So we need a numerator to also be positive. So ln of x is more than 0, and ln of x is more than 0 after 1. So I've just got the ln of x graph here. We start at, it's negative until 1, and then after 1 it's positive. So ln of x is positive when x is more than 1. So if x is more than 1, the entire fraction is positive. I'll just repeat my logic there. So on the bottom we got x to the power 4, and that's always positive when x is positive. And then on the top we got ln of x, which is only positive when x is more than 1. So therefore, to get the entire fraction positive, you need x to be more than 1. Finally, sketch the graph of f showing clearly the value of the x-intercept and the approximate position of p. Okay, so p is about here, and that is e to the power a quarter 1 over 4e. That's roughly where the maximum is. And you've also got x equals 1 here, where it starts to become positive. So that's 1, 0. This is where the function becomes positive. It stops being negative, it starts being positive, because we found that out in part D. And there's only one maximum and there's only one minimum. So therefore, so there's only one maximum, there's no minimum. There is no minimum. So it's going to look something like this, where it's asymptotically goes down to infinity here, and then it has an asymptote here, and it never actually goes negative again. It always stays positive because you've got a maximum. It's never going to have a minimum again. So it's going to always stay positive, but never have a minimum. So it's never going to turn back up. So the graph's going to look like that. Question 9. A biased four-sided dice A is rolled, and X is the score obtained when the dice is rolled. The probability distribution for X is given in the following table. So you've got a table, and we're trying to find the value of P, and we're also trying to find the expected value of X, E of X. The symbol E of X means the expected value of X. And we zoom in, and we know that to find probabilities, all probabilities must sum to 1. So P plus P plus P plus a half of P is 1. You've got 3 P's plus a half of P, that's 3.5 P. Or we can write that as 7 over 2P. That's 3.5P as a fraction. And we're going to rearrange that to find what P is. Multiply by 2 and divide by 7, we've got P equals 2 sevenths. That is the answer to part A. Now, to find the expected value of X, we're going to multiply. So 1 times P is P, 2 times P is 2P, 3 times P is 3P, and 4 times a half of P is 2P. And we'll add all those together, like this. And that gives us 8P. But we know that P is 2 sevenths, so we substitute that in. And 8 times 2 sevenths is the same as 16 sevenths. And now we've got the value of the expected value of X. Good. Now a second biased four-sided dice is rolled, and Y is the score obtained when B is rolled. The probability distribution is shown in the table. State the range of possible values of R, and hence find the range of possible values of Q. So we know that R is a probability, so therefore it can be anywhere between 0 and 1. So there's nothing else to worry about with R, it's just between 0 and 1. 0 is less than or equal to R, is less than or equal to 1, because it's a probability. And hence find the possible values of Q. Well, Q, we know that Q plus Q plus Q plus R is 1. And we can simplify that to be 3Q plus R is equal to 1. And we know that the smallest value of R is 0. And we know the largest possible value of R is 1. So let's try and figure out what the biggest and smallest values of Q are. So we're going to just consider the range of possible values of R to help us find the range of values of Q. So if R is 0, 3Q plus 0 is 1. So therefore, and if R is 1, 3Q plus 1 is 1. So if R is 0, we rearrange, we get Q is a third. Where if R is 1, take R off both sides, we get 3Q is 0, and therefore Q is 0. So Q could be any value between 0 and a third. 0 is less than or equal to Q, is less than or equal to a third. Okay? So we found the values of Q and we found the values of R. Good. Now, C, it says state the range, we go to part D now. It says hence find the range of values of E of Y. Okay, so E of Y is the expected values of Y, and we get that by adding up by multiplying Y by the probability. 1 times Q is Q, 2 times Q is 2Q, 4 times R is 4R, etc. And adding them all together. So E of Y is Q plus 2Q plus 3Q plus 4R, which is 6Q plus 4R. And we can substitute in our values to figure things out here. So, E of Y is 6Q plus 4R. Now, we need to think about our combinations of R and Q here. So, we're going to start by substituting Q is a third. And we know that if Q is a third, R is 0. Because that is the combination that I need to make 1. So 6 times a third is 2, plus 4 times 0 is 0. So that gives us E of Y is 2 there. Whereas our other combination of Q and R is when Q was 0 and R was 1. So we can put Q is 0 and R is 1 into there. 6 times 0 plus 4 times 1 is 4. So e of y is between 2 and 4. And I just need to emphasize here, the reason I chose 0 and a third as one combination, because that is the combination I added to make the full probability of 1, and 1 and 0 is another combination that also added to make a full probability of 1. When I substitute those in, I get e of y is 2, e of y is 4. And therefore e of y is between 2 and 4. 2 is less than equal to e of y, is less than equal to 4. Done. Now, the very final question on the paper. It says, Agnes and Barbara play a game using these dice. Agnes rolls dice A once and Barbara rolls dice B once. The probability that Agnes' score is less than Barbara's score is 1/2. And it says find the value of e of y, and we have a convenient equation for that already, which we used in part D. E of y is 4q plus 6q plus 4r. And here we want to find when Agnes' score is less than Barbara's score, so we're going to draw a probability tree here to find all the combinations where Agnes' score is less than Barbara's score. And here I've drawn it. I've drawn Agnes' scores 1, 2, 3, or 4, and I've drawn Barbara's scores branching off of that, which are also 1, 2, 3, and 4. And we only care about when Agnes' score is less than Barbara's score. I'm going to highlight that here. So all these branches here is when the second score is more than the first score. So for example, I've got the branch 2, Agnes scores a 2, then Barbara must score a 3 or a 4 for it to be more than that. When Agnes scores a 3, it must be a 4 afterwards to get more than that. And when it's a 1, it must be 2, 3, or 4 to get more than that. So they're the combinations we care about. So immediately we can simplify this tree and make our life a bit easier. So let's simplify that. And this is the only tree you actually need to draw in the exam to make life a bit quicker for you. And the probabilities of scoring a 1, a 2, or a 3 for Agnes is P, P, or P from the table. And for Barbara, she's got a probability of Q, Q, and R, Q, and R, and R. So when it's a 4, it is R. When it's any other number, it's not a 4. And we're going to multiply to go across the branches like this. So these probabilities must sum to be 1/2, because in the question it says that the probability that Agnes' score is less than Barbara's score is 1/2. So all these probabilities here, all these combinations make 1/2. And so we're going to add all those up together to make 1/2. Okay? And this simplifies P times Q plus P times Q plus P times Q is going to simplify to be 3PQ, and then we've got PR plus PR plus PR is 3PR. Conveniently, also we've got another equation linking Q and R, and that is that 3Q plus R must be 1. That's from earlier in the question when we noticed that Q plus Q plus Q plus R was 1, because those probabilities must add up to 1. We rearrange and we've got R is equal to 1 minus 3Q. And we've also got that this equation here simplifies to 3PQ plus 3PR. And we're going to replace all the R's in that equation with 1 minus 3Q, like this. And now we've got an equation with only P's and Q's in. And we can also replace the P with our value of P, which earlier in the question we found was 2/7. So that's going to replace all the P's here. The P here is going to be replaced by 2/7, and the P here is going to be replaced by 2/7. And now we've only got an equation with Q's in. And we can solve that equation even if it does look quite scary. We're going to slowly start simplifying this. 3 times 2 is 6, 3 times 2 is 6, so we simplify that fraction. And we expand that bracket. 6/7 times 1 is 6/7. 6 times minus 3q is minus 18q. We get rid of divide by 7 by multiplying by 7. That's really nice. Get rid of divide by 2 by multiplying by 2. Like this. And we've not got any fractions anymore, which definitely helps make things simpler. 12q minus 36q is minus 24q. And so 7 equals 12 minus 24q. And we rearrange, we get 24q equals 5, divide by 24, and we've got q is equal to 5/24. Okay, a lot of nasty algebra there, but that's why it's a 6-mark question. Okay, so you can do that if you take your time and go step by step by step. Okay, if you rush there, you will make mistakes, so be careful. We've not quite there yet. We need to find e of y. And so for that, we'll need r as well. So r is 1 minus 3q. I'm going to substitute in q is 5/24, which makes 1 minus 15/24, which is 1 minus 5/8, because 15/24 simplifies to be 5/8, which is 3/8. So r is 3/8. And e of y, just substituting in our fractions, 6 times 5/12 plus 4 times 3/8 is 30/24 plus 12 over 8. Simplify, we get 10/8 plus 12/8 is 22/8, or 11/4, and that's the final answer. We have finished. We have completed the entire paper all the way through. We did not use a calculator at all. It was a fully non-calculator test. Some of that paper will be probably quite difficult. I would really recommend that if there's a question you don't like, you can ask questions below in the comments. You can watch my other videos on that specific topic to help you boost your confidence with it, or you can rewind and watch that part of the video again. Thank you for watching this video from Advanced Maths. Remember to like and subscribe. It really helps support the channel. If you found this really useful, you can also share with your classmates, your friends, or family. Thank you for watching. You could also check out advancedmaths.com for more super useful IB practice. All of our advance is completely free, and we don't do ads either. So all of this is entirely about giving you the best revision resources to help you succeed in your exams. Have a great day and good luck in your exams.